Yep, I started recording.
Is it okay?
Yep. Yeah, you go ahead. I've started recording. Yeah. Hello.
Hokuto, you're muted.
Could you unmute yourself, please? Hokuto? Could you unmute your mic? Hokuto? We can't hear you.
Sorry.
Yeah.
I'm sorry. The connection was bad. So thank you for the introduction. And I'd like to thank the organizers for giving me this opportunity. And maybe Shione kindly upload the file of my note, right?
Yes,
on the chat
I will post it on the
already.
chat.
Already?
Not yet. I'm good. I'm going to do it now.
Okay. Thank you very
Okay.
much. So
you go ahead.
Yeah, sometimes I may write so quickly, so please download it. Okay, so the title is Exceptional Correction on the Hirzebruch surface sigma 2. Hirzebruch surface containing -2 curves. And this is a joint work with Akira Ishii in Nagoya and Shinnosuke Okawa. Maybe Shinnosuke is here. And well, so let me start. So in my talk, varieties are always smooth projective over the complex number field, and dx is always means bounded derived category of coherent sheaves. And okay, so this is just introduction, so I won't give the precise definition, but SOD is a decomposition of derived category into smaller pieces of triangulated full subcategory. And full exceptional correction is a finest SOD. I will give the precise definition later. But exceptional correction on a derived surface are studied by Kuleshov and Orlov. And so today, I want to generalize their result to weak derived surface, namely Hirzebruch surface containing -2 curves, okay? And yeah, well, new ingredient is, well, a weak derived surface, which is not, if it's not del Pezzo, contains -2 curves. And if we have -2 curves, we can define a highly non-trivial autoequivalence called twist functor associated some line bundle on the -2 curve C inside sigma 2. So for example, yeah, Kuleshov Orlov proves that every exceptional object is a shift of vector bundle or line bundle on -1 curve. But on the other hand, because on sigma 2, there are highly non-trivial autoequivalence twist factor. So if we have structure shift on sigma 2 and twist by something, then this object of derived category, O sigma 2 is an exceptional object, and apply the twist factor many times, then we can obtain exceptional object which has arbitrarily many non-vanishing cohomology. I mean, on derived surface, exceptional object is just a shift of sheaf, but on sigma 2, there are much more complicated exceptional objects. So that makes the problem, the problem to study exceptional correction makes it much more difficult. Okay, so let me define some terminology. Okay, so definition. E object of derived category is called exceptional if R on E is just K. So I mean no higher X and just a one-dimensional hom. Namely, okay. This is in this case E is called an exceptional object, and secondly, if we have several exceptional objects, and E bar is a ordered set of exceptional object of length m is called exceptional sequence. Exceptional correction of length m if R hom E I E J vanish for I greater than J. So I mean, yeah. And thirdly, if exceptional correction E bar generates derived category, which means that smallest triangulated full subcategory containing each EI, E1, EM, coincide with the whole derived category DX. In this case, we call exceptional correction E bar generates. Then E bar is called full exceptional correction. And yeah, in this case, if M is length E bar, we can see that Grothendieck group of K is generate these EI, namely Z EI, I is 1 to M. So abstractly, it is just a free abelian group of rank M. Okay. And when I write ECMX, it is a set of exceptional correction of length M, exceptional correction of length M modulo isomorphism, yeah, and FECX is E bar, is a subset, it's not necessary. FECX means the set of full exceptional correction inside DX. And I will give some example. And for example, if HIOX is 0 for I greater than 0, and take a line bundle on X, then because XILL is one-dimensional if I is 0 and 0 otherwise, so L is an exceptional object. And second example is on sigma 0, namely P1 cross P1, I call it standard exceptional correction on sigma 0, which is defined structure sheaf and O01 and O11 and O21. We can check that this is a full exceptional correction on sigma 0. Okay. And I also use later the following exceptional correction on sigma 2, namely OP1 plus OP1 minus 2, and E2 standard defined as follow, namely O, OF, OC plus 2F, and OC plus 2F, where F is a fiber of P1 bundle. And we can also check that this is a full exceptional correction on sigma 2, but the detail is not important, but just afterwards I will use a deformation argument, and we can see that sigma 2 deformed to sigma 0, and on that space, this standard exceptional correction on sigma 2 deformed to the standard exceptional correction on sigma 0. Okay. And next, I will introduce mutation. And there is a way to construct new exceptional correction from the old one. Namely, well, if we have a exceptional pair, which means just a exceptional correction of length 2, then we can construct a new exceptional correction new exceptional pair by so-called right mutation and left mutation. By left mutation, I can define, like, we can construct a new exceptional pair, LEFE. And using this operation for a given exceptional correction of length M, K, E, K plus 1, E, M in exceptional correction of length M, we can define the new exceptional correction by this mutation, namely RKE defined by E1, EK plus 1, REK plus 1, EK, and doesn't change anything except these two terms. So I mean, this exceptional pair change this exceptional pair by right mutation. And similarly, we can define left mutation, case left mutation as follows, namely L, E, K, E, K plus 1, E, K, and doesn't change anything except these two terms. And this new external correction of length M. And well, they satisfy the following relation, namely RK, LK, E bar equal LK, yes. E bar equal E bar, and braid relation, and braid relations. So, I mean, braid group acts on the set of exceptional correction of length M, namely braid group of M strand. This is a braid group of M strands acts on the set of exceptional correction of length M, and also the set of full exceptional correction. If the length M. So because the property full is preserved under the mutation. Okay. And also the free abelian group of rank M acts on this set. E K shifted by 1 and E K plus 1 and so on. So Zm also acts on the set of exceptional correction. So I mean, I denote Gm. Sorry. Any questions so far? Well, sometimes I'm very worried that some people can hear me or not. Okay, and let us define GM semi-direct product of Zm and Bm braid group of M strand. So therefore, this group GM acts on exceptional correction of length M and full exceptional correction of length M. And there is a famous conjecture due to Bondal and Polishchuk. So if we have assume that there exists exceptional correction of length M such that E bar is full, then this action is transitive. And as its corollary of this conjecture, exceptional correction of length M coincide with full exceptional correction. Because as I said, the property full is preserved under the mutation. And also, I assume there is one full exceptional correction, and the action is transitive. So all exceptional correction of length M is full. Okay? Okay. So let me explain something about autoequivalence. 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 So if I denote autoeq this means a group of autoequivalence of dx. And of course, if we have a exceptional correction and we have a autoequivalence, then we can get a new exceptional correction. And usually, no, always, autoequivalence group contains the following, always contains the following subgroup, which is generated by pick x and auto x and shift functor. And usually the left-hand side is strictly larger than the right-hand side, but sometimes they coincide. And twist functor actually, well, in the element of right-hand side is called standard autoequivalence. Standard autoequivalence. And twist functor, which I will define now, is not a standard autoequivalence. Well, precisely if the dimension is greater than the dimension of the variety is greater than or equal to 2. So definition is if alpha is called spherical object, if R hom alpha is just C plus C shifted by dimension X. And also alpha tensor omega X is isomorphic to alpha. If alpha satisfies this property, it is called spherical object. An example is C is -2 curve on a smooth surface, and the line bundle on the -2 curve is spherical. In dx. And associated to this spherical object, we can define the following non-trivial autoequivalence. And for a given spherical object, we can define the autoequivalence group, autoequivalence T alpha associated with this spherical object, which is called twist functor, satisfying the following property, namely for any beta in dx, there is a distinguished triangle R hom alpha F tensor alpha and we consider evaluation map and taking the mapping cone. And yeah, this is a distinct triangle. Okay. And actually by this distinct triangle, if dimension x is even, T alpha as the element of automorphism group of Grothendieck group is reflection. So I mean, we can say if the variety has even dimension, twist factor is a categorification of reflection. Okay. Any questions so far? It's okay. Okay. And remark. There is a famous theorem due to Bondal and Orlov. If plus or minus k is ample, for example, x is sigma 0, p1 cross p1, then any, well, autoequivalence group is generated by the standard one, namely automorphism group, Picard group, and shift factor, which is denoted by AX. And so in this case, autoequivalence group is very simple. And on the other hand, Ishii and Uehara, myself, proves that autoequivalence group on sigma 2 is generated by F2 and standard autoequivalence, where F2 is generated by twist factor, as I define now. And actually, this is generated by twist factor along spherical, along line bundle on -2 curve of degree A. And actually, we can also see, we can also check that this group is generated by just 2 elements, or C. And where C is -2 curve. And actually, we can prove this group is free group of 2 generators, this generator. So that's why I denoted F2. Okay. So main result. Before stating our result, I want to refer Kuleshov Orlov result on derived surface. And let X be a derived surface, and M is the rank of Grothendieck group of X. And first result is, I call it classification. For any E exceptional object, there exists I integer such that E shifted by I is a line bundle on a -1 curve, or a vector bundle. Maybe it's exaggerated to call it a classification of external object, but it's just a name. So, okay, and second result is transitivity. Transitivity. So action of mutation and shift functor acts on the set of external correction of length m is transitive. Namely, in this case, Bondal Polishchuk conjecture is true. And as I said, as its corollary, external correction of length m, the set of external correct, so ECMX coincide FECX. And third result is constructivity. So for any external correction of length L, where L is less than or equal to M, can be extended to E bar in external correction of length M. And also this coincides full external correction by the second result. Any question on this theorem? Okay. And remark, as I said, autoequivalence group. Well, no, I don't need it. As I said, on sigma 0, autoequivalence group is generated by the standard one. So, but on the other hand, on sigma 2, autoequivalence group is strictly larger than the standard autoequivalence group. So there are so many, there are more external object and external sequence on sigma 2 than on sigma 0. So that's why our theorem is much more complicated than this theorem, Kuleshov-Orlov. Well, I said it's complicated, but in some part, we reduced the proof to the result in Kuleshov-Orlov by deformation argument. Okawa and myself. Let X be a sigma 2, namely P1 bundle over P1 containing -2 curves. And first result, for any exceptional object, there exists phi autoequivalence such that phi E is a vector bundle. And second result is transitivity. G4, mutation and shift factor acts on the set of exponential correction of length 4 is transitive. And third result is constructivity. And for any E prime bar, exponential correction of length L, where L is less than or equal to 4, can be extended to E bar in exponential correction of length 4. Okay, so let me explain some idea of the proof of these result. So for F coherent sheaf on X, I define LF to be the rank of C on C of torsion part of F, where C is a -2 curve. And for E, sorry, E exceptional object E, exceptional object E in EX, I define LE to be the summation of length L of the cohomology, ice cohomology of E. And this is greater than or equal to 0. And we can see that LE is 0 if and only if E is a vector bundle up to shift. So we can also check, that there exists I0 A S integer, integers such that I0's cohomology of E is E0 plus T, where E0 is exceptional sheaf and T is torsion sheaf. And also taking direct sum of the cohomology HI, where I is not I0, and the sum of T appeared above, plus torsion E0 is the exceptional sheaf appeared in I0's cohomology, is isomorphic to OCAS plus OCA plus 1 length of E minus S. So I mean, well, this E0 suppose E0 is just X, but so I mean, there uniquely exists an integer I0 such that support of the cohomology I0's cohomology of E has the support of I0's cohomology is just X, and other cohomology, the support of other cohomology is contained in the minus 2 of C. And actually, we can prove we can prove stronger statement, namely this sheaf is actually OC module and also we can prove by the rigidity of exceptional object we can restrict the degree of the sheaf on C as follows. And by this observation, then we can find integer b such that the length OCB E is smaller than the length of E. And by the induction process, there exists phi in TOCB is integer such that phi E is a vector bundle, because as I said, we can see that if the length is 0, then E is a vector bundle up to shift. This is the idea of proof of the classification result. And the idea of proof of the second statement, I mean, transitivity is much more complicated. And we use deformation argument, and there exists a deformation f x to spec kt, and this is a generic point such that carry 0 is isomorphic to sigma 2, and chi eta bar, geometric generic fiber is isomorphic to P1 cross P1. So, I mean, our weak derived surface sigma 2 deformed to derived surface sigma 0. And given exceptional object E in E sigma 2, well, basically by the vanishing of higher x1 and vanishing of x1 and x2 of E, we can find out exceptional, some object on carry x such that E restricted to x0 is isomorphic to the original one, and script E restricted to x eta is exceptional object in the sigma 0. And because such E, script E uniquely exists, I denote this generic E. Okay. And first claim is for any external correction of length 4, there exists sigma in G4 generated by mutation and shift. G4 is a group generated by shift and mutation, such that on the glutamic group level, the class of sigma E bar coincide with the class of standard external correction on sigma 2. So I mean, on the glutamic group level, transitivity can be proved by in this claim. So I denote Gen 4. This is a map defined by this pink letter Gen E. This is the set of external correction of length 4 on sigma 2 to EC4 sigma 0. So we have the following commutative diagram, namely we have the set of external correction length 4 on sigma 2, and we have map Gen 4 and for sigma 0. And taking the class of glutamic group, I denote this map K0, and K0 sigma 2 plus 4, and K0 sigma 0 plus 4. And actually, we can check that, by the deformation, we can naturally identify these group. It's just a Z4. And we have external correction length 4 here. This is given. And take the image and Gen 4 E bar. But because the transitivity result due to Kuleshov and Orlov on derived surface sigma 0, there is a transitivity result. So there exists sigma 4, there exists sigma G4 such that sigma E0 bar standard. And this goes to K0 E bar, and this goes to K0 sigma E0 STD bar. On the other hand, we have a standard external correction on sigma 2 here and sigma. But deformation is compatible with mutation action, so this is sent to this. And this goes to this. And this goes to this. But Gen E4 also goes to K0 Gen 4 E bar, and this goes to this. So I mean, by this equality, by this equality, we can prove the equality on the glutamic group level as well. But this is isomorphic, so we can see that desired equality here. This is claim 1. Okay, any question? And claim 2, for E bar in external correction of length 4 with on the glotonic group level, E bar coincide with the standard external correction on sigma 2. Then there exists phi is generated by 2 times spherical twist T alpha 2 such that phi E2 bar is E bar. So I mean, if E bar external correction of length 4 with some property on the glotonic group level, we can find such autoequivalence. Idea is very similar to idea of truth is similar to one in the first statement. So yeah, and claim 3 is for any phi in F2. This is generated by twist functor, and there exists tau in G4 such that phi E2 standard is equal to tau E2 standard. And yeah, and this case, basically mutation and twist functor commutes, autoequivalence commutes. So enough to check, it's enough to check phi is a generator of F2, namely TOC or OC -1. So through his done by concrete calculations. And so now I want to explain how to prove transitivity result. And I explain these claim 1 to 3 and combine these for given external correction of length 4 by claim 1, there exists sigma generated by mutation and
Hello, it's frozen. Can anyone? Hokuto? Can anyone hear me?
Yeah, I can hear you. I think Hakuto's connection is
Yeah.
lost. Yeah. I think he will return.
Yeah,
at
he's
some point.
not here.
Саша, привет.
Привет, а что ты комнату-то сменил?
Я на кухню перешел.
Другой. А что у тебя
Там у
на
меня
карте
была...
в районе Камчатки висела какая-то рвакта? Что это за рвакта висела в районе Камчатки?
Где эти делают? Кузя, аккуратно. У меня тут кот хулиганит.
Ну,
Сейчас
я
покажу.
страшная жизнь. А я видел уже как-то.
Идем, я тебя познакомлюсь с Сашей. Вот мой кот.
Great cat. He or she?
И Кузя, Кузьма.
Кузьма.
Кузя, say hi.
Doesn't like to meet me.
Yeah, he's very free cat. Yeah.
Cats are usually free.
Yeah.
Nice to meet you. Meeting was not long.
Yeah. He's in the playing mood. Like to play with things. Kuzya, stop. Yeah. Sasha, are you in Brazil now?
Of course. Why should I change my beautiful place? You see, this is my room. This is a little part of my house. By the way, you are very welcome to visit us. We will find for you everything you want. If you will be in Brazil, just let me know.
Саш, конечно, с удовольствием. Как все закончится, с удовольствием приеду. Я с Каролиной еще
Что
работаю.
закончится? Я
закончится.
пенсионер.
Ты
я
ушел
на
уже?
пенсию ушел. Да, сбылась мечта идиота. И вообще нечеловечески хорошо себя чувствую. Просто
хорошо, да?
Да, отделался от всех этих идиотов-студентов. То есть ничего не надо больше. Вообще кайф просто. Занимаешь а еще коронавирус помог хорошо. Потому что теперь не надо никуда ездить. Кругом семинары. Вот твой, например. В общем, жизнь... знаешь, такой анекдот. Там мужик вешается... приладил там веревку, залез на табуретку, смотрит на шкафу полбутылки водки. Жизнь налаживается. Вот у меня жизнь налаживается. Вот. Очень хорошо. Там стыковка, ты, наверное, знаешь, там все семинары, понятно. Никоновский семинар, да. Кайф.
Слушай, я все знаю, времени нет. Если честно. У меня куча проектов каких-то тут.
Да я знаю тебя, Ваня. Ты весь в проектах. Ты, так сказать, один не успел.
Мы доделываем большой проект, и он оказался намного больше, чем мы думали. В общем, то есть как так планировали доделать к концу декабря, но понятно, что еще месяца на 3. Нет, причем все же как математически почти все доделано. Там просто куча писанина, то есть там...
Иррациональное что-то?
Да, можно сказать. Проблема коллаби для многообразия фана.
Фана я не фан фана.
Не, это...
Я не
Ой,
знаю.
я большой фэн.
Да, ну
О,
понятно.
Hokuto is back. Hokuto is back, yeah.
It's nice.
Oh, it's already Christmas time. Hokuto, hello. Welcome here.
Oh,
Сергей, Merry
this is-
Christmas.
yeah. Hello. Can you unmute yourself?
Sorry, can you hear me?
Yeah.
Yeah.
Yeah, sorry. The one line proof is left. So could you show the last page of my slide? Because my computer cannot be connected. Just iPad can be connected. So
Oh, okay. Let me share this one. There you go.
last page. Yes. So just combine claim 1, 2, 3. We can prove tau E2 standard is equal to sigma E. So E and standard one can be connected by the action of G4. That's finished. So I stop here. Thank you very much. And I'm sorry, I apologize.
Okay, thank you. Any questions?
I have small question. Can you do the same for all weak del Pezzo surfaces?
I believe so. But because configuration of -2 curves is very complicated, so that's why we cannot accomplish it.
But maybe with help of computer or something, because no?
Well, I'm very poor at computer, so I don't know.
Mm-hmm. Anyone else? Okay, I think we'll let's yeah, thank Hokuto again. Thanks.
Thank you very much. And I sincerely apologize. So thank you.
No worries, we got you back again. Yeah.
Sorry.
And Merry Christmas to everyone.
Merry Christmas.
Yeah.
Sorry. Bye.
Bye. Bye, Siane. Nice to see you. Bye, Sasha. Bye, everyone.
Bye everyone. Bye, Park.